Welcome to the session on K-fold cross-validation. This is widely used technique in machine learning for model evaluation. The concept we are going to discuss is K-fold CV. In K-fold cross-validation, we split dataset into K equal subsets, which is called folds. We train the model on K minus 1 folds and test it on the remaining fold. This process is repeated k times, each time using a different fold for testing. Finally, we average the results across all folds to get the final performance measure. So this is an example: training set observation and testing set observation. So the analogy for k-fold CV. Let us take an example for predicting the student exam scores. We will assign k equal 5. Let's understand this with an example. Suppose we have 100 students and we divide them into 5 equal groups of 20 each. In cycle 1, we train on 80 students and test on 20. In cycle 2, we train on another 80 and test on next 20. We continue this until every student has been part of the test set once. At the end, we collect accuracy scores from all cycles like 82%, 85%, 81%, 84%, and 83%, and then compute the average, which here is 83%. This average represents the final model performance. So why this is useful? K-fold cross-validation is very useful because it makes the most out of the data set. Every data point gets used for both training and testing at some point. It also reduces bias from relying on just a single train test split and gives us a more reliable estimate of how well our model will perform on unseen data. Here is a Python example that shows how K-fold works. We create a simple dataset with 12 samples, then we split it into 4 folds using scikit-learn's K-fold function. The visualization shows each fold as a row where red blocks represent training samples and blue blocks represent test sample. As you can see, each sample gets a chance to be in the test set once while being part of the training set in the other folds. Let us have a small quiz. Imagine you are at a large amusement park with different rides. You want to evaluate how much fun the park really offers. Instead of trying just one ride and judging the entire park, you try each ride once. Each time you leave out one ride for testing and enjoy the rest of the training, which is for practice. At the end, you average your experiences across all rides to get a fair judgment of the whole park. This is exactly how K-fold cross-validation works. Instead of judging a model with only one train test split, we test on each fold once and average the performance. So, to sum it up, K-fold cross-validation splits the datasets into folds. Each fold gets tested once, while the rest are using for training. The final score is the average across all the folds. Just like testing every ride in the amusement park gives you a fair opinion, K-fold CV gives you a reliable measure of model performance.